It makes me really happy to see all of you here. So thrilled. Yeah, it just makes my heart happy. It's why we do these lectures. So really appreciate seeing all of you here. So I'm Karen Silkaitis. I'm the Dean of Arts and Sciences here at the University of Alaska Southeast. I express my appreciation, and you're all like, I don't know who you are. So that's why I am. And I'm really, really happy every time that I have the opportunity to host Evening at Egan. Arts and Sciences took it over a couple of years ago, and it's one of my very favorite things to do here. So I want to begin tonight with our land acknowledgement. Our campuses reside on the unceded territories of the Occoquan, Tontoquan, and Sheetquan on Tlingit Ani, also known as Juneau, Ketchikan, and Sitka, Alaska. We acknowledge that Tlingit peoples have been stewards of the land on which we work and reside since time immemorial, and we are grateful for that stewardship and incredible care. We also recognize that our campuses are adjacent to the ancestral home of the Hadas and Tsimshian, and we commit to serving their peoples with equity and care. We recognize the series of unjust actions that attempted to remove them from their land, which includes forced relocations and the burning of villages. And we honor the relationships that exist between Tlingit, Hadas, and Tsimshian peoples and their sovereign relationships to their lands, their languages, their ancestors, and future generations. We aspire to work toward healing and liberation, recognizing our paths are intertwined in the complex histories of colonization in Alaska. We acknowledge that we arrived here by listening to the people's elders' lessons from the past, and these stories carry us as we weave a healthier world for future generations. Scott Billingsley, where are you? Scott, I saw Scott. Scott in the back. Scott's always standing back there. I usually like to acknowledge if we have members of our executive cabinet here. Aparna Palmer, our chancellor, is currently traveling for a very special family event. So Aparna's not here tonight, but we do have our new provost, Dr. Scott Billingsley, standing back there in the back. So thanks for being here tonight, Scott. Scott, I know, also wants to get to know community members, just like Aparna Palmer does. So thanks for being here. The other thing I wanted to do tonight was preview a couple of our other evening at Egans that we're going to have next and give you just a little taste of what's coming your way. And I'm so excited that our next lecturer just happens to be sitting right there. Dr. Logan Berner is our next lecturer for November. And I'm really excited about that lecture too. So Logan, I'm just challenging all of these people right here to come back for your lecture also. Logan is a really incredible speaker. The first time I heard Logan speak, I was teasing him that I'm a theater person. I know it's shocking. I'm like, I love a microphone. I can run. Anytime you put one in my hands, I feel like the faculty at UAS are like, oh, pull the mic away. But my pedagogy is theater and performance. But I'm a secret science geek. I love science so much. And if I wasn't going to be a theater person, I used to always say that I wanted to be a marine biologist studying sharks. And one person said to me once, oh, we don't have any in Alaska. And I was like, yes, you do. You have salmon sharks, you have sleeper sharks. They're so cool. And so I know a lot about sharks. And there's a little part of me that wishes I had done that, when I was studying in college. So I love theater, but I'm a secret science geek. And the first time I heard Logan speak, it was a lecture that he gave at the Alaska Coastal Rainforest Center, which is one of our partnerships here at UAS. And he was so captivating. He's such a good speaker. So I'm really excited about Logan's talk. He is doing Arctic ecosystems in a warming world. And I'm super excited for you to talk in November. So that is November 14th, 7 p.m. Snacks, just like we had tonight. I know you come for us, but I know you like snacks. We all like snacks. Logan's going to talk about how climate change is transforming life in the Arctic. There's rising temperatures that are causing trees and shrubs to spring up where they never did before. How does that affect animal life also in the Arctic? So he's going to give a great lecture in November. And then The last evening at Egan is something that I know you've come to know and love. And Lily Hope is the one that named that lecture, and that is called Winter Fire Showcase. And I have to say it like Lily says it every time. So it's Lily Hope, it's Emily Wall, and it's Ernestine Hayes. And I know all your faces just did that when I said Ernestine Hayes, because who does not name girl over her? I do. And it's me. And so it's Emily Wall, Ernestine Hayes, Lily Hope, and Steve. And we're all going to do some performances for you that night. We're going to preview some of our new work that we're writing. It's a bunch of creatives that are going to get on stage, and you don't know what irreverent things are going to come out of our mouth, because I know some are going to come out of mine. All right, so you should come to that. That is going to be Friday, December 12th, right here, and you don't want to miss it. All right, and now we have something very special in store for you. It's really my honor tonight to introduce Dr. Kevin White. I was so excited when I heard about this lecture. I was like, oh, who doesn't love mountain goats? Who doesn't want to talk about mountain goats? And right, you said there are people who, there's a bunch of you nodded when I said that. And who doesn't want to talk about mountain goats and avalanches? And then Dr. Eran Hood said to me, and there's going to be really beautiful pictures. And I was like, mountain goats, avalanches, and really beautiful pictures. I am in. Dr. Kevin White is a wildlife ecologist with us. So Kevin works with us in the program on the environment in the Department of Natural Sciences. He received a PhD from the University of Victoria, an MS degree from the University of Nevada, and a BS degree from Humboldt State University. Kevin conducted field studies on mountain goats and moose in Alaska for the last 20 plus years. His research focuses on understanding how weather and climate influence population ecology of wildlife, particularly in rapidly changing mountain ecosystems. So a subject for which, I want to get this right. Hang on. Y'all know, I'm at the point in my life where I need readers. And it's a sad, sad day because my wife is sitting up there and I'm always like, Chrissy, can I borrow your thoughts? Because I don't bring the reader. Tonight I brought them. Just good for all of you, because who knows what I would have just said about your paper if I had them on my head. Okay. Okay, a subject for which the climbing bearded beast, the color of winter, the mountain goat, or jambu, is well suited for study, given its role as a sentinel species of alpine environments. That's beautiful. His work is supported by Alaska Climate Adaptation Science Center, along with a multidisciplinary network of project collaborators, including Alaska Department of Fish and Game, Alaska Division of Geological and Geophysical Surveys, Swiss Federal Research Institute for Snow and Avalanche Research, and the University of Victoria, and more. And please give it up for Dr. Kevin.
Wow, thank you for the great introduction, and thanks everybody for coming tonight. I'm excited to talk to you about our research on mountain goats and avalanches. And this has been, let's see. Advancing. There we go. This has been an exciting multidisciplinary collaboration amongst many different researchers, including snow and avalanche and natural hazard scientists, as well as wildlife ecologists from a number of different universities and institutions. And I'd like to acknowledge my collaborators here on this slide. Okay. And I would also like to acknowledge that our research is taking place on the traditional territory of the Tlingit people, who have retained relationships with mountain goats and the land for millennia. Climate change is occurring rapidly in mountain ecosystems relative to surrounding lowland areas. And in these environments, environmental challenges can be extreme and impose challenges for the persistence of life in mountains as compared to other systems. The often extreme conditions belie that these systems can be sensitive to small shifts. For example, when temperature averages hover around the rain and snow tipping point, such as occurs in our coastal ecosystems. Juneau, for example, has an average winter temperature of 31 degrees. And so small shifts in temperature can result in rain or significant amounts of snow and transforming the physical environment. And understanding change in mountain populations is critical in these rapidly changing environments and for the systems themselves and those that rely on them. Despite their extraordinary adaptations, mountain species can be especially sensitive to variation in environmental conditions. And the study of sentinel species, such as mountain goats, offer important opportunities for understanding change in these systems more broadly. Snow is an ubiquitous feature in mountain environments and blankets the landscape for 9 months of the year and significantly influences the organisms that live in these mountain environments. Snow is an important landscape altering force and exerts strong effects on physical as well as biological systems. Within this context, snow can play a strong role in influencing mountain ungulate population dynamics. In this picture, this was taken in December 2020, following six days of severe weather following an atmospheric river depositing 96 inches of snow in alpine environments. And you can see in this picture of these three mountain goats the way in which snow is strongly influencing their lives in these mountain environments. They've dug deep shelters into the snow to reduce the impacts of wind on them in these alpine environments. And there's deep furrows in the snow that is strongly influencing their ability to move around in this snow-filled environment. And snow can, so snow can influence populations via indirect or ecological mechanisms as well as direct physical pathways. And so in this diagram, I'm show how weather and climate influences snow, and snow can influence the summer nutritional landscape that mountain goats and other alpine herbivores experience, as well as influencing the distribution and availability of thermal refugia, for which cold adapted species like mountain goats are particularly sensitive to hot days in summer, for example. And in winter, snow can influence their ability to move around in the landscape and can increase their energetic costs of locomotion, such as was illustrated in the previous slide. Snow also can bury forage, reducing their availability to forage resources that are important for survival to their nutrition, as well as their survival over winter and subsequent reproduction, factors that ultimately influence population growth and viability. And avalanches represent an unexplored but potentially significant direct pathway by which snow can influence survival and hence population dynamics through direct mortality, for example, which can influence survival and also growth and population viability. And these mechanisms ultimately can influence at a broader level ecosystem dynamics and biodiversity. So in this talk, I'm going to focus on the avalanche part of this equation, a process that is maybe particularly important, but it's been scarcely examined. And the impacts can be both good and bad. Avalanches are unquestionably a key disturbance mechanism in mountain environments. And avalanches can provide benefits to mountain species. For example, they may facilitate earlier spring green-up in areas that have avalanched, as is illustrated by these two panels of pictures that were taken in the Summit Creek watershed near Haines. The first was taken on April 20th, and you can see on the right-hand side where there is spring snow avalanches on going down and sloughing snow off of the landscape. About a month later, coinciding with when mountain goats are giving birth to offspring and have high energetic demands, you can see that those slopes are now greened up with emergent vegetation that is highly nutritious and critical for them to keep up with the energetic demands of lactation and caring for offspring nutritionally. And so in this way, avalanches can provide benefits to animals by extending the growing season in areas that slid compared to areas that are surrounding it that are still buried under a deep blanket of snow. But such benefits can also occur during winter as well. And this is a really interesting observation that occurred in mid-February. There is a glide avalanche, an avalanche that goes all the way down to the soil surface, and it exposed vegetation of which mountain goats from the surrounding area moved into this area that had slid to access this recently uncovered vegetation in an environment that is otherwise buried in a couple meters of snow. And in this picture, there's actually 9 mountain goats. In the upper part where it's sort of fractured and sloughing, there's 6 mountain goats. And then down along this edge, there's 3. So these animals, as I touched on before, move from the surrounding environment. And I kind of have illustrated in where the trails were, and then highlighted the area in green where there was vegetation that they were foraging on. And so in this way, avalanches actually were providing probably a fairly significant food resource for mountain goats during the time of the year when they're really struggling nutritionally. But avalanches can also be costly and result in direct mortality, as is illustrated in this photograph of a mountain goat that died in the late spring avalanche. So mountain goats utilize steep, rugged terrain to avoid the risk of predation. And this behavior may carry important costs, such as those associated with the difficult to detect risks associated with avalanches. So animals are making trade-offs between predation risk as well as the risk of avalanche mortality. And life in extreme environments is risky and involves a delicate balance. And so that is for species like mountain goats that are well adapted to living in an extreme environment. They have low growth rates, low reproductive rates, and that translates into low population growth rates. So perturbations can have perturbations such as avalanches, for example, or other factors can have relatively long-lasting effects on mountain goats. And so it's important, I think, for us to think about these dynamics in a system like this that's particularly sensitive. And so with that, I'm going to talk about our research objectives. And so we focused on sort of 4 different topic areas. The first was trying to characterize the spatiotemporal patterns, or how avalanche mortality varies across space, geographically, and across time. And then also we wanted to try and learn more about why are mountain goats dying in avalanches. And then ultimately the extent that populations are affected. And then ultimately, what are the conservation implications of these relationships? So next I'm going to talk about our study system. And so we studied mountain goats in 4 different study areas in southeastern Alaska, up around the community of Klukwan and Haines and Skagway, along the eastern side of Lynn Canal, on Baranof Island, and down in a small population on the Cleveland Peninsula. The snow climate in these environments is typically a temperate maritime climate, but in the very northern part of the study area, up by the near Haines and Klukwan, by the Canadian border, there's a transitional snow climate. Mountain goat populations in this area vary in terms of their population trends and are generally speaking at relatively moderate densities. Populations generally are migratory, such that they summer in high elevation alpine areas, and then with the onset of snowfall around this time of year, they'll shift down to lower elevation, still steep, rugged mountainous environments, but areas that are at lower elevation with typically less snow, not only because of elevation, but because of the forest canopy that can intercept snow. Other notable species in these systems that mountain goats are overlap with include moose, deer, brown bears, black bears, wolves, coyotes, and wolverines. Except on Baranof Island, and that system, it only includes deer and brown bears. And here I have a few pictures of these study areas, the Lynn Canal in the upper left, the Klukwan study area near Chilkoot Lake, which maybe some people are familiar with, Baranof study area in the bottom left, and the Cleveland Peninsula. And one of the things that kind of jumps out at you is the amount of snow in this landscape and the steepness. And if you look carefully, on a lot of these mountainous areas, you can see places where avalanches have cascaded down from the alpine, in some cases all the way down to sea level. In fact, our analyses suggested that about 60% of our study areas that mountain goats were inhabiting were comprised of avalanche terrain. So these animals are living in an environment that have a lot of avalanche terrains, and avalanche is a very present risk that they're contending with. And so in order to accomplish these objectives, we analyzed long-term data. This is data that I collected previously when I worked for the Alaska Department of Fish and Game, and was analyzed via a data sharing agreement. We collected data from 4 different study areas across a 17-year period. And this involved capturing animals, over 400 animals, and deploying them with GPS VHF radio collars, which enabled us to monitor their movements in detail, as well as detect survival and mortality, to monitor survival and detect mortality events. Over the course of these studies, we monitored individual mountain goats over 1,174 mountain goat years, and documented 242 mortalities. And so we focused on studying mountain goats, but we also conducted work to be able to characterize avalanche terrain across our study area. And this is work that was done particularly with our collaborators, Gabe Wolken and Yves Buhler, using the RAMS avalanche simulation model to delineate avalanche terrain across our study area. And then we also conducted demographic modeling to be able to understand the extent that avalanches are affecting population dynamics. And I'll go into a little bit more detail on that later. So here I have a 3-dimensional map that illustrates the way in which we integrated mountain goat data and avalanche modeling. And so on this 3-dimensional map, you see the blue outlines, and those are delineating avalanche release zones, as well as the pass and then the deposition areas. And the red dots and interconnecting lines are GPS locations for mountain goats, the path that this mountain goat took over the course of about, this individual female mountain goat took over the course of about a 1-month period. So the first thing that jumps out at you is this animal is spending a lot of time in avalanche terrain. The triangle illustrates the last known live location of this animal, and the cross is where that animal died and was recovered in avalanche debris. So this is kind of information combined with aerial and field investigations enabled determination of the cause of death, and also evaluation of the amount of time that individual mountain goats were spending in avalanche terrain. So here I have some results, and these pie charts are illustrating the proportion of mortalities that were caused by avalanches in red and caused by other causes in light blue. And the top pie chart illustrates the overall patterns, such that 36% of all mortalities were caused by avalanches. And then I have it broken down by the 4 different study areas, and we see that it varies across the areas from as low as 23% of mortalities were caused by avalanches in Lynn Canal, and as much as 65% in the Baranof study area. So clearly avalanches are an important source of mortality amongst mountain goats, comprising over 1/3 of all mortalities. And what's interesting and particularly critical is that a large fraction of the mortalities that are occurring are impacting prime-aged animals. And in this graph here, I'm illustrating that 54% of all female mortalities were comprised of animals in prime age classes, animals that are particularly important for reproduction in the population. And this source of mortality differs from other sources such as malnutrition or predation, which are typically killing young and old animals that are not contributing that much to mortality. And so avalanches, in a sense, are largely randomly removing animals from a population, which is what we expect because we consider avalanches to be a wicked problem or one that occurs in a wicked and learning environment. So that means that individuals have a very limited opportunity for trial and error learning because when they encounter an avalanche, they oftentimes die. So this is particularly important for population dynamics as a source in relationship to a source of mortality. And this is something that has important implications downstream that I'll get into more as we move forward. This panel shows avalanche mortalities on the right y-axis across the different months of the year. And what we see is that most avalanches are occurring in early winter and in late winter. These are periods of time that we know that avalanche or the snowpacks are least stable. And indeed, we're finding that mountain goats are most frequently dying during these periods of time when the snowpack is least stable. And to try and provide insight about why animals are dying in avalanches, we summarize the amount of time that each individual animal spent in avalanche terrain for each month, and then cross-reference that with whether or not the animal died in an avalanche or not. So the animals that died in avalanches are in the red, and the ones that didn't die in an avalanche are in the blue. And so what we see is that across the months that female animals that died in avalanches spent more time for every month in avalanche terrain than those that did not. So indeed, individuals that are dying in avalanches are living more dangerously. And so how does this translate and scale up to the population level? And so in this panel, on the y-axis, I have the 4 different areas. And then on the x-axis, the horizontal one, it's the proportion of the population that died by avalanches. And so what we see is that on average, about 7% of mountain goat populations are being removed or killed by avalanches in a given year. And that there's some variation between the different study areas, but there's also a lot of variation amongst years. And so the lighter dots are the estimates for a given year for a given study area. And so we see in some years, virtually no animals have died in avalanches, but in some years we have as many as 22% of a population dying in avalanches. And across most study areas, we have years where at least 15% of the population died in avalanches. And so when we cross-reference that with the average population growth rate of mountain goats, which I mentioned before was low, on average it's about 1.5% growth rate. So the population can increase 1.5% a year. And then we take into consideration the fact that maybe 22% of a population is removed by avalanches. That is likely to have very significant impacts on the population and might result in a significant population decline in a pretty long time for a population to recover. So in order to investigate this question, we conducted some population modeling. And so we used the empirical data that we collected in our studies. And the goal was to start on the very top, we can start with an initial given population size, say 100 animals, and then we can simulate across a range of different scenarios. So in our case, like the best case scenario, the average scenario, and the worst case scenario, how many animals would you expect and from what sex and age class are removed by avalanches? We can then calculate the survival rates for the individuals that survived, and then the subsequent reproductive rates. So how many animals did those guys reproduce to calculate the estimate of the population 1 year later. And so in that way, we can look at different simulations for how, or different scenarios for how avalanches are impacting populations and look at the change from 1 year to the next. And in cases where there's a population decline, we can then calculate the recovery time, or how long would it take a population to recover following a given decline event. And so what we found is that in the worst case scenario, avalanches can precipitate a 15% population decline. And that can take up to 11 years for a population to recover from, which equates to 1.5 mountain goat generations. So one bad avalanche event can set a population back for a generation or more. So that's pretty significant, and that provides us with some important insights about how snow and subsequently avalanches can impact mountain goat populations. On average, populations can sustain avalanche mortalities, and the population can still grow at about 1.5%. In the best case scenario, if there's no avalanche mortalities, a population can increase about 6.6%. But one of the things that is important to notice is that the difference between the average and the best case scenario is a lot less than the difference between the average and the worst case scenario. So it could take multiple best case scenario years to be able to counteract one really bad year. But on average, it can take 11 years for a population to bounce back from the worst case scenario. And so next, I'm going to touch on the conservation implications. And the high rates of avalanche mortality that we document might be widespread among mountain wildlife, and if so, carry important cultural and ecological implications. Mountain goats play important roles in mountain communities. Tlingit people and indigenous people all along the Pacific coast, and also in interior regions inhabiting the range of mountain goats, have long relied on mountain goats for subsistence, as well as weaving chilcats and raven's tail blankets, such as these pictured on the far left that were woven by Terry Rothkar. But avalanches can also, through provision of food, ungulate carrion, can also be subsidizing scavenger food webs in mountain ecosystems that otherwise have relatively low ungulate biomass, such as wolverines. There's a picture of a wolverine scavenging on a mountain goat, both in the upper right, lower left. In this picture, there's a brown bear that's digging into an avalanche, trying to excavate a mountain goat that died in that avalanche, with a black bear waiting potentially patiently on the side. And then the upper left, this is a picture of a mountain goat that died, that a coyote, a bald eagle, and a raven are all fighting over. And the fact that these animals are fighting over it or taking risks, such as the case of the black bear and the brown bear, to be able to access these food resources provides an illustration of how important these food resources are for these carnivores. And so I also want to kind of close with talking a little bit about mountain goats and climate change. And so earlier we did some studies that were focused on looking at how climate change might impact mountain goat populations through ecological mechanisms for mountain goat populations in coastal Alaska. And this work that suggested that across a range of different general circulation model and emission scenarios, that mountain goat populations were not likely to fare well. We've also conducted other analyses and synthesis of data showing the different ways in which climate and weather, and ultimately climate change, can impact mountain goat populations, which is sort of illustrated on the far left. But this kind of raises the question of how will climate and avalanche dynamics alter these projected outcomes. And so what we know from or what we know about avalanches in weather and climate relationships is that some of the key drivers of avalanches relate to the structural weakness in the snowpack, and then the amount of snow that's on top of different layers in the snowpack. And so avalanches can be precipitated if you have even a relatively stable layer, but on top of that, if there's a huge amount of snow, that can cause that layer to fail and cause a slide. Alternatively, if you have a really weak layer, it doesn't take a lot of snow to be able to trigger that slide. And so those are important sort of fundamental mechanisms to understand in order to kind of think about how climate change might influence avalanche occurrence and frequency and distribution across the landscape. Some work that Colin Shanley did in 2015 and co-authors involves modeling and predicting how climate will change in our coastal Alaska environments. And one of the things that they predicted is that there's likely to be less alpine snow, but more rain on snow. And so we might be seeing the snowpack becoming less at lower elevations, but maybe staying the same and shifting higher up in elevation. So we might see a shift in the distribution of where avalanches are occurring across the landscape. Gabe Wolken and Yves Buhler, a couple of the collaborators on this work, have an independent project that's focused on trying to learn more about and investigate these dynamics. Work in other places of also other parts in other mountains around the world have documented this pattern of upward shifts in elevation of avalanches, and other and study areas in the Rocky Mountain states have suggested that they may expect to see shifts from cold, dry avalanches to warm, wet avalanches. Warm, wet avalanches lead to greater risk of entrapment amongst animals that are caught in those avalanches, and potentially higher mortality. So we have some initial insights, but overall, I really want to emphasize that there's important need to learn more and about the relationships between climate change and avalanches, and that we really don't have a comprehensive or strong understanding of these relationships, but we do have some initial insights about these relationships and how these might be changing in the future that can kind of help us think about how mountain goats' risk associated with avalanches might be changing. And so finally, the relationships that we document for mountain goats may be far-reaching. Mountain goats with avalanche hazard currently cover 6% of Earth's land area and occur on all continents, with 32 species of mountain ungulates across 70 countries inhabiting a substantial fraction of this range. And here I have sort of highlighted in this map the areas in red. This is actually from independent publication, but they highlighted where mountain ranges are across the world. And have pictures here of some of the key mountain ungulate species that inhabit these different ranges around the world. And so our work, I think, provides like some important insights about mountain goats and our coastal ecosystems, and they likely translate to other ecosystems, not just in North America, but probably throughout the world. I've had informal conversations with colleagues who study Dall sheep and bighorn sheep that have likewise documented comparable levels of mortality from avalanches in those systems. So this is an important area of research, I think, and can provide needed insights for helping with management and conservation of mountain goats and other mountain ungulate species going into the future. And so with that, I would just like to acknowledge the different sources of funding that have made this study possible, including the Alaska Climate Adaptation Science Center, UAS, our collaboration and data sharing agreement with the Alaska Department of Fish and Game, and many other institutions that provided funding for this work. many different field biologists that I worked with over the years and pilots, as well as collaborators that were key for making this project what it became. And so with that, if there's time for any questions and if you're interested in more information.
Thank you so much. We are going to run around with some microphones so that people online can hear your questions. Got another one under here too. Let's get this one on.
And actually, if you could repeat the question before.
Okay.
instead of working it back.
And so this is yours. Let me
All right.
make sure we're still. Leon, great. Okay. All right, you keep yours. And
Okay.
these. So anybody has questions? Niall. Also, you got one up there.
Ye- ye-
Animals are lost that way.
Yeah, so the question was how many animals are lost by hunting? And so the focus of our work was on looking at natural causes of mortality. And so the principal causes, as I touched on, were avalanches, malnutrition, predation by brown bears, black bears, and wolves, and a few other causes. Hunting occurs in most of the study areas that I was working in, and is generally closely regulated by the Alaska Department of Fish and Game. Typically, harvest pressure at most would comprise about like 2 to 3% of a population. That's sort of like the general recommendation for based on population modeling work that we've done, for example. And so that would be sort of kind of on top of these different sources of mortality, these natural sources of mortality that I'm talking about. But I will mention that, hunting of mountain goats is widespread throughout Southeast Alaska. And but it's limited. The amount of animals that are actually harvested is limited by access. And so it's difficult for hunters to get up into the mountains and find a mountain goat. And so a lot of harvest is typically occurring in places that have relatively decent access. A lot of the areas where we were studying mountain goats are pretty remote and difficult for people to access. And there's pretty limited, if any, harvest historically. And so a lot of the area that I worked in, I would say, is not exposed to very much, if any, harvest, with some areas that have better access and that are consistently harvested at that kind of guideline harvest level.
Any other questions? Oh, right here.
Yeah.
I had one question. I noticed that Baranoff had a higher percentage of avalanche caused mortality. And I was just curious, do you think that was caused by terrain or Baranoff's proximity to a maritime influenced climate? If you guys had any clue to that.
Yeah, that's a great question. So the question was about why the proportion of animals that died from avalanches was higher on Baranoff Island compared to the other areas, and why. And so there's a couple possible things that are going on. And so one is that I mentioned that about 60% on average of across the study areas of the area was comprised of avalanche terrain. But that varied generally between 57 and 67% amongst the three primary study areas, with Baranoff having the greatest amount of avalanche terrain. So there is more avalanche terrain on Baranoff Island. And then, as you touched on, we don't have like good snow records for elevation, but just anecdotally, we know that Baranoff can get really significant amounts of snow because it's wetter, closer to the ocean. And then the other factor is that Baranoff Island, the only consequential predator of Baranof Island, natural predator are brown bears, whereas on the mainland there's wolves and black bears. And then of course, brown bears during the wintertime are in hibernation. And so generally the survival rates of mountain goats on Baranof Island are higher. There's fewer ways for them to die. So that means that more animals are dying from avalanches than other places. So it's probably a combination of those three different things.
So you have a question. The other mortality, at the beginning, you were showing that the avalanche shoots, show, need more food and those kind of things. Would did your models take into consideration, or did you consider the factors of perhaps less malnutrition deaths in areas with the high avalanche, or the influence of those avalanche clearings on success or not success in predation, any of those kind of things?
Yeah, so great question. Thank you for asking that. So the question is that are avalanches sort of compensating for other sources of mortality, such as malnutrition and predation? And so it's something I didn't really get into here, but we did look at the relationship between, try to understand the extent that avalanche mortalities were compensatory, which means that they're killing animals that would have already died, or whether they were additive and that the mortalities from avalanches were adding on to the ways in which animals are dying from other causes. And so what we found is that from average to high levels, that most avalanche mortalities were additive. So they're adding on to existing sources of mortality. But at lower levels, they're more compensatory. So there's fewer animals that are dying from avalanches, and there's a chance that some of those animals that are dying from avalanches would have died from other causes. So it's sort of less impactful at those lower densities for that reason as well.
Hi, thank you. I'm wondering, do you know what the predictors are for whether it's going to be a bad year for mountain goats and avalanches? Is it simply just that there's a lot of avalanches that year and the snowpack is unstable, or are there other factors that could play into that?
Yeah, that's a really good question. And, we actually got Bill Glued here, who's a avalanche forecasting expert. He probably has better insights than me, but I think that going into a winter, it can be hard to predict like what kind of winter you're going to get, especially in our environment where we have so much variation in weather. But some of the things that can be kind of important is like if you have like a rain on snow event, for example, and then you have cold weather after that, you can kind of have a hard crust in the snowpack, or there's other ways you can get like weak layers. And sometimes those weak layers can persist in the snowpack for the entire winter. So that's kind of one possible way that like early in the season, depending upon the way that the storms come in and the conditions kind of shake out, you can then have a sense for whether it's going to be sort of a bad year or not. At a broader level, like there has been people that have looked at like these sort of like longer term climate oscillations like El Nino or La Nina. And so sometimes like we'll see periods of time where we typically might have runs of years where we have, like colder years, or runs of years where we have warmer years. And there's been some work in British Columbia that have used some of these indices to sort of kind of project and examine the extent that that's related to avalanche kind of mortality or accidents in humans. So there's some knowledge about that, but I think that it's something that there's kind of certainly a need in our area to kind of have a better understanding of, and there's opportunity to learn more about that, because we live in an area that is not really heavily populated, so like some places there's like ski areas and huge heli ski operations and tons of people in the backcountry. And there's a huge amount of people that are involved in like monitoring snowpacks and forecasting all across the landscape. And here we have relatively few people, with Bill being one of the key ones. But yeah, so yeah, that's kind of my sort of, generalized kind of interpretation of that. Man, that's a great question. So the question was, how high do mountain goats climb? And so, in our study area, one of the high, or in one of our Lynn Canal study area, one of the highest mountains is called Mount Sinclair. And if you go up Lynn Canal from Juneau to Haines, it's like all the mountains that are on to the right, and it's like this really cool prominent peak. It's about like 6,800 feet, I believe. And I was looking at our mountain goat locations from the GPS collars, and there was actually some that were like right near the summit. So that's the highest that I know of around here. Thanks. That was a good question. Thanks.
Just like to pull the thread a little further on a couple of questions that room before, beyond the scope of your study, which I know the scope is mostly on this part of North America, and then just a couple of decades, but perhaps aside from avalanches or predation or for whatever the reasons, looking past over like centuries or even millennia, are there other known reasons why these type of animals populations have either or cause the population to grow more or decrease?
Yeah, so the question was, I guess, over long time spans, do we have other indications for why populations might grow or decrease? And so that's a great question. Like I could maybe reference that by like existing studies and my knowledge of work that's been done in our area as well as throughout the range, going back to some of the early studies in the 50s and 60s. And there's been different case studies where, heavy snow years being a common driver of population declines, for example. We see that here in Southeast Alaska, not just with mountain goats, but with moose and with deer. We'll have some big winters. We've had some in recent years where you might have 3 or 4 feet of snow on the beach, and those can be pretty detrimental and elicit significant population declines in mountain goats, moose, and deer, for example. And those kind of factors influence populations widely, sort of throughout these mountain ecosystems in North America where mountain goats occur. Summer drought can be an important driver, particularly in southern areas. One of my collaborators was working on mountain goats in Washington State in the Cascades and documented summer drought being an important driver of mountain goat survival. And so kind of one of the things I touched on earlier was how snow influences hydrology and then ultimately like nutritional quality and availability across the landscape. So it's kind of tied into that dynamic. In some instances, not so much in recent years, but early on, like in management of mountain goats, like over harvest was an issue. I think that before people really learned a lot about the population biology of mountain goats, in particular their low reproductive rates, they didn't appreciate like how sensitive they could be to harvest, and oftentimes they would be managed like deer are with higher harvest rates. In some instances, predation can play an important role. There's been a couple of fascinating case studies in the Canadian Rockies and then an introduced population in South Dakota, which has documented the impacts that mountain lions can have on mountain goats. And it's an interesting dynamic because mountain goats are really well adapted to avoid the risk of predation by using these steep, rugged terrain, but it's principally an adaptation to predators like wolves and bears, where mountain lions are pretty capable of clambering around in steep, rugged terrain. And so in places where there's mountain lions, they can have impacts on mountain goat populations. And so that's kind of like, a little cross section of some of the important drivers that have been identified across mountain goat populations. Kind of in more recent times, one of my collaborators, Daria Marchenko, she was a population geneticist, and she actually sequenced the mountain goat genome and was able to look back in sort of like deep time, going back, tens of thousands of years, and documented what appeared to be evidence of a bottleneck, and which meant that populations went from a high level to a low level that was associated with the last glacial maximum. And so when there was like the last glaciation, covered a lot of areas that are now important mountain goat habitat. And so populations there in that time probably shrunk quite a bit, and then they've sort of since been expanding. So to touch on some of those topics, that's sort of some of the things that I know about that.
Evan, I say I've got one more, and you're going to be my last one for tonight. Allison, do you want to get in there?
Yeah. Will you tell the story about the mysterious goat collar that came back to life?
Goat collar that came back to life.
Yeah, thanks, Lori, for. Yeah. Yeah, so that's a really fun question. Thanks, Lori, for asking that one. And this relates to an instance where we radio collared a mountain goat over by in the upper part of the Katsine River watershed near the Meade Glacier, which is sort of kind of to the southeast of Haines. And it was a older female mountain goat. And this was, I believe, the winter of 2006 and 2007, which was a really severe winter. And early in the winter, this animal died, due to the severe winter conditions, and was, just like getting buried deeply under the snowpack. And so we weren't able to get back to the site to recover the collar until the following spring. And when we got to the site, we are usually where you have like a radio, the collar is emitting a radio frequency that we can hone in on with an antenna on a radio receiver, and hone in on where that collar is, and collect the collar. So we got dropped off. We hiked into this site. We found like the location where there was like goat hair and bones and remains around, but we couldn't find the collar. And it was really kind of unusual because that had never happened before. These collars are really ruggedly made, and even if a bear came along and chewed on it, it's unlikely that it would be able to prevent it from emitting the signal. And so we just kind of, like signed it off as like a mystery. We weren't really sure what happened. And then, so typically what I would do is I would radio track all of our radio collared mountain goats like once a month or sometimes more frequently. I'd listen to all the unique radio signals, and then I could be able to track in on them and see if they had a kid or learn about their status. And I just kept this signal, this frequency, like in our receiver, and just would check on it. Like, who knows, maybe it's going to come back to life or something. And sure enough, it did, except it was 3 miles away from the original site. And I was like, what could possibly be going on? And we couldn't see where it was. It was like in thick alders. And so we came back again. And the third time we came back, and we tracked in on this frequency. And it was like up in the alpine. And finally we're like, we're finally going to see it. And we're circling, and we're like, there's a black bear. And we're like, the black bear has a collar on. Looks just like the collar from the mountain goat. And sure enough, it turned out to be the black bear had came across this mountain goat that died at the end of winter, scavenged on it. And then, because bears are so curious, it managed to put the collar on and collared itself and walked around for 1.5 years with this mountain goat radio collar on. Yeah. Yeah, it's pretty.
Did you get it back?
Yeah, and so all these it turns out like all these radio collars that we put on, they have a remote release mechanism. So before the battery dies, they automatically release. And so after a year and a half, and the battery is due to run out of juice, the collar popped off, and we went and collected it in like a salmonberry patch, and where the bear was hanging out foraging in fall. Yeah, that was one of the more remarkable things that we observed over the course of these studies.
Well, thank you. I want to thank you so much for coming out tonight and remind you that we have 2 more evening at Egan's coming up. Dr. Logan Berger is next. And lastly, I could not do this without the amazing staff that we have in arts and sciences. So one more round of applause for my staff. George, Riley, Allison.